a man changed how we see the universe. But for telling the truth, he was punished. In a world where the church decided what people were allowed to believe, one scientist dared to look through a telescope and say, "Everything you know about the heavens is wrong." His name was Galileo Galilei. He wasn't a king. He wasn't a priest. He wasn't even meant to be a scientist. He was just a curious student who asked dangerous questions. When Galileo discovered the moons of Jupiter, he proved that Earth was not the center of the universe. When he supported the heliocentric theory, he challenged centuries of religious belief. And when he refused to stay silent, the most powerful institution in Europe turned against him. The church called him a threat. His ideas were banned. His books were burned. And in the final years of his life, he was placed under house arrest. Old, blind, isolated. Yet even then, Galileo kept writing, kept thinking, kept pushing humanity forward. This is a story of a man who looked at the stars and changed the world forever. In the year 1564, in the Italian city of Pisa, a child was born who would one day challenge the way humanity understood the universe. His name was Galileo Galilei. At the time, Pisa was a proud city of stone towers, narrow streets, and ancient traditions. The world still believed the Earth stood motionless at the center of the cosmos, while the sun, stars, and planets revolved around it like obedient servants. These ideas were not just scientific beliefs. They were religious truths, deeply tied to the power of the church. No one could have guessed that this small newborn, wrapped in cloth and resting in his mother's arms, would grow up to question everything. Galileo was born into a musical and intellectual family. His father, Vincenzo Galilei, was not a nobleman or a politician. He was a musician, composer, and music theorist. But Vincenzo was more than just an artist. He was a thinker, a man who believed that knowledge should come from experiment and observation, not blind tradition. This belief would shape Galileo's entire life. Vincenzo often challenged old musical rules. He tested different strings, sounds, and instruments to understand how music truly worked. Instead of accepting what books said, he trusted what his ears and experiments revealed. Little Galileo grew up watching his father question authority, test ideas, and search for truth through evidence. Without realizing it, Vincenzo was teaching his son the most important lesson of all. Never accept something as true just because powerful people say it is. Galileo's mother, Giulia Menotti, was a strong and practical woman. She focused on managing the household and raising her children. Life was not always easy for the Galilei family. Money was often tight, and Vincenzo had to work hard to support them. Still, the home was filled with music, discussion, and learning. Young Galileo listened as his father spoke about sound, mathematics, and harmony. He heard debates about science and philosophy. He grew up in an environment where curiosity was not punished. It was encouraged. From an early age, Galileo showed signs of an active and questioning mind. He wasn't satisfied with simple answers. He wanted to know why things worked the way they did. Why did objects fall? Why did music sound different on different strings? Why did the stars move across the night sky? While other children played games, Galileo often found himself observing the world around him. He watched how water flowed. He studied how shadows moved with the sun. He noticed patterns in nature that others ignored. As Galileo grew older, his family moved between Pisa and Florence, two important centers of Italian culture. Florence was a city of artists, architects, musicians, and thinkers. It was the birthplace of the Renaissance, a time when Europe was rediscovering ancient knowledge and pushing the boundaries of art and science. In Florence, Galileo was surrounded by great works of art, beautiful buildings, and intellectual conversation. The city breathed creativity. Painters studied human anatomy. Sculptors shaped stone into living forms. Thinkers debated philosophy and mathematics in crowded rooms. This environment fed Galileo's curiosity. He began his formal education in Pisa and later continued in Florence. He studied reading, writing, logic, and classical texts. But Galileo was not just memorizing lessons. He questioned them. His teachers taught the ancient ideas of Aristotle, whose teachings had ruled science for centuries. According to Aristotle, heavy objects fell faster than light ones. According to Aristotle, Earth stood at the center of everything. Most students accepted these ideas without question. Galileo did not. He wondered, has anyone actually tested this? Even as a young student, Galileo was more interested in experimenting than memorizing. He wanted proof. He wanted evidence. One famous story tells of Galileo climbing the leaning Tower of Pisa and dropping two objects of different weights to see how they fell. Whether the story is fully true or not, it reflects something important about his character. Galileo believed that nature itself was the true teacher. Not books, not tradition, not authority. Nature. At home, Galileo also learned music. following in his father's footsteps. He studied the lute and explored how sound traveled through strings and air. Music taught him about mathematics, patterns, and vibrations. These lessons would later help him understand physics and motion. In many ways, Galileo's childhood was a perfect mix of art and science. He lived among painters, musicians, and scholars. He heard melodies and mathematical discussions. He saw beauty in both sound and numbers. This combination shaped how he saw the world. To Galileo, the universe was not just something to observe. It was something to understand. As a teenager, Galileo showed great talent in mathematics. His teachers noticed his sharp mind and problem-solving skills. His father wanted him to study medicine, a career that promised stability and income. So Galileo enrolled at the University of Pisa to study medicine. But his heart was not in it. While other students focused on anatomy and treatments, Galileo found himself drawn to geometry and physics. Numbers fascinated him more than the human body. Motion interested him more than medicine. He began spending more time with mathematicians than doctors. Eventually, Galileo made a bold decision. He left medical studies behind and chose the uncertain path of science and mathematics. This choice disappointed his father at first. Medicine was safer. Science was risky. But Galileo believed that understanding the laws of nature was more important than financial security. And so, his journey truly began. During these early years, Galileo was not yet famous. He was not yet controversial. He was just a curious young man trying to understand the world. But his way of thinking was already different. He didn't accept ideas just because they were old. He didn't believe something just because powerful people said it. He trusted observation, logic, and experiment. This mindset would soon bring him recognition and conflict. Because in a world ruled by tradition and religious authority, curiosity was dangerous. But Galileo didn't know that yet. For now, he was simply a student, walking the streets of Pisa and Florence, listening to music, studying mathematics, and looking up at the stars, unaware that one day, those stars would change his life forever. As Galileo grew older, his curiosity only became stronger. While other boys in Pisa were learning to follow rules, Galileo was learning to question them. He didn't just want answers. He wanted reasons. And more importantly, he wanted proof. His father, Vincenzo, often brought musicians, scholars, and thinkers into their home. These visitors debated music, mathematics, philosophy, and science late into the night. Young Galileo would sit quietly in the corner, listening. He didn't speak much, but he absorbed everything. Vincenzo taught his son that true knowledge comes from testing ideas, not just believing them. When musicians argued about sound, Vincenzo experimented with strings. When scholars claimed certain notes were superior, he measured vibrations. Galileo learned something powerful from this. Truth does not belong to authority. Truth belongs to evidence. This lesson stayed with him forever. In Florence, where the family later spent much of their time, the atmosphere was electric with creativity. The Renaissance was in full bloom. Painters were studying anatomy. Architects were designing grand structures. Sculptors were shaping marble into lifelike figures. And everywhere, people were asking questions. Florence was not just a city. It was a living classroom. Galileo walked through streets filled with art, music, and discussion. He visited churches decorated with masterpieces. He heard musicians perform complex compositions. He saw engineers experimenting with machines and structures. All of this shaped his mind. To Galileo, learning was not something that happened only in school. It happened everywhere. In markets, in workshops, in music halls, in the sky above. At night, he would often look up at the stars. The heavens fascinated him. The stars moved in perfect patterns, yet no one truly understood why. People believed what ancient books said, but Galileo wondered if those books were right. What if they were wrong? As he continued his education in Pisa, Galileo became known for his sharp intelligence. He was especially skilled in mathematics. Numbers made sense to him. They were precise. They followed rules that could be tested and proven. Unlike philosophy, mathematics did not rely on opinions. It relied on facts. His teachers noticed his talent. Some admired him, others were uneasy. Galileo asked too many questions. He challenged ideas that had been accepted for centuries. In a time when respect for tradition was expected, Galileo's curiosity stood out. One day in Pisa, Galileo watched two chandeliers swinging inside a cathedral. He noticed that no matter how wide the swing was, the time it took for each swing remained nearly the same. To most people, it was just a chandelier. To Galileo, it was a mystery. He began timing the swings with his pulse. He observed the movement carefully. He made notes. This simple observation would later help him understand motion and gravity. But at the time, Galileo didn't know he was making history. He was simply curious. His love for music also continued to grow. He practiced the lute and studied harmony. Music taught him about rhythm, vibration, and balance. These ideas later helped him understand physics. In Galileo's world, art and science were not separate. They were connected. Music followed mathematical patterns. Nature followed physical laws. The universe, he believed, was written in the language of mathematics. As Galileo approached adulthood, his father pushed him toward a practical future. Medicine was respected. Doctors earned good money. Science, on the other hand, offered little security. So Galileo enrolled at the University of Pisa to study medicine. But his heart was elsewhere. While other students memorized anatomy, Galileo studied geometry. While they learned treatments, he explored motion and measurement. He was more interested in how things worked than how to heal them. Soon, he began skipping medical lectures and attending mathematics lessons instead. His professors noticed. Some warned him. Others encouraged him. Finally, Galileo made a life-changing decision. He left medicine. He chose science. This was not an easy choice. It meant uncertainty. It meant financial risk. It meant walking a path few others dared to walk. But Galileo believed something deeply. Understanding the universe was worth the risk. By the late 1580s, Galileo had already begun developing his own ideas about motion, physics, and mechanics. He designed small machines. He conducted experiments. He wrote notes filled with observations. He was no longer just a student. He was becoming a scientist, yet he was still unknown to the world. No fame, no controversy, no enemies. Just a curious mind, searching for truth. Little did he know, his questions would soon shake the foundations of Europe. Because the universe he was about to describe was not the universe the church believed in. And the truth, once discovered, could not be hidden. In the late 1580s, a young Galileo Galilei walked through the stone gates of the University of Pisa with a future already chosen for him. He was not there to become a famous scientist. He was not there to change the world. He was there to study medicine. His father, Vincenzo, had made the decision with care. Medicine was a respected profession. Doctors earned good money. It was a safe path in an uncertain world. For a family that often struggled financially, stability mattered. Science, on the other hand, was risky. Philosophy was unstable. Mathematics paid almost nothing. So Galileo followed his father's wishes and enrolled as a medical student. At first, he tried to take his studies seriously. He attended lectures on anatomy, disease, and treatments. He memorized the names of bones, muscles, and organs. He learned about blood, fevers, and ancient medical theories passed down from Greek and Roman scholars. But something felt wrong. Galileo listened to his professors speak, but his mind wandered. The lectures were filled with old ideas that no one questioned. The same books were used year after year. The same theories were repeated without proof. To Galileo, it felt like learning without understanding. Medicine focused on the body. Galileo's curiosity focused on nature itself. He wanted to know why objects moved, why things fell, why the universe behaved the way it did. While other students studied illnesses, Galileo found himself staring at moving objects, swinging chandeliers, rolling balls, and falling stones. He was more interested in motion than medicine. One evening, inside Pisa's Grand Cathedral, Galileo noticed something simple but powerful. A large chandelier hung from the ceiling, gently swinging back and forth. Most people saw a light. Galileo saw a mystery. He watched how the chandelier moved. He noticed that whether the swing was wide or narrow, the time it took to complete each swing stayed almost the same. He measured it using his pulse. Again, and again, and again. This observation planted a seed in his mind. A seed that would later grow into his understanding of time, motion, and gravity. But at the university, no one was teaching these ideas. Medicine offered answers. Mathematics offered questions. And Galileo loved questions. Soon, he began spending more time with mathematics students than medical ones. He attended lectures on geometry, numbers, and physics. He explored how shapes, distances, and forces could explain the physical world. This is where he met Astilio. Rishi Ricci was not just a teacher, he was a guide. Rishi believed that mathematics was the key to understanding nature. He taught Galileo how numbers could describe motion, structure, and balance. He introduced him to the ideas of Archimedes, the ancient Greek scientist who used math to explain physical laws. For Galileo, it was like discovering a new language, the language of the universe. Rishi showed him how mathematics could measure reality, how equations could explain movement, how geometry could describe space. Under Ricci's guidance, Galileo began to see the world differently. The universe was not mysterious chaos, it was organized, predictable, mathematical, and for the first time, Galileo felt truly alive in his studies. Medicine now felt distant, boring, lifeless. Science felt exciting. While his classmates memorized medical texts, Galileo filled his notebooks with diagrams, calculations, and experiments. He studied falling objects, inclined planes, and mechanical devices. He tested ideas instead of accepting them. He wasn't just learning, he was discovering. His professors began to notice. Some admired his brilliance. Others were irritated by his questions. Galileo didn't just ask what, he asked why. And sometimes, he asked, is this even true? In a university built on tradition, such questions were dangerous. Medical studies were based on ancient authorities like Galen and Hippocrates. Their words were treated as law. To question them was to question centuries of accepted knowledge. But Galileo believed something different. Truth should be tested, not worshipped. The more Galileo studied mathematics and physics, the clearer his path became. Medicine was not his future. Science was. Eventually, he made the decision that would change his life forever. He left medical studies behind. He chose mathematics and natural philosophy. This decision was not easy. It meant disappointing his father. It meant losing financial security. It meant choosing uncertainty over safety. But Galileo had found his passion, and he was willing to risk everything for it. His father, though worried, slowly began to understand. Vincenzo himself had challenged musical traditions. He knew what it meant to follow truth instead of comfort. Galileo soon began teaching private lessons in mathematics to support himself. He explained geometry to students. He solved complex problems. His reputation as a brilliant mind began to grow. Still, he was not famous. Yet, he spent long nights experimenting. He built simple machines. He observed motion. He wrote notes that filled pages with ideas. He was no longer just a student. He was becoming a scientist. But this was only the beginning. The discoveries that would shake the world were still ahead. For now, Galileo stood at the edge of history, armed with curiosity, mathematics, and a fearless desire to understand the universe. And the universe was about to answer him. By the time Galileo Galilei reached his late teens, he was no longer a boy, curious about music or art. His mind had turned toward the natural world, toward questions that no one around him dared to ask. Medicine had once seemed a noble pursuit. His father, Vincenzo, had dreamed of seeing his son become a physician, respected and secure in society. But for Galileo, memorizing the names of bones and learning to cure fevers could not satisfy the questions burning in his mind. He wanted to understand how the universe itself worked. He found the walls of Pisa's medical classrooms confining. Professors spoke with authority, repeating centuries-old ideas as if they were unchallengeable truths. Galen's teachings, the standard for medicine at the time, dictated how the body worked. And yet, for Galileo, following authority was never enough. He wanted proof. He wanted evidence. Every lesson on anatomy felt incomplete. What use was knowing that blood flowed in veins if he could not understand why it flowed, or how it obeyed the same forces that made a ball roll down a hill or a pendulum swing? To Galileo, the laws of the body were not separate from the laws of nature. They were connected, and mathematics was the key that could unlock them all. It was during this restless period that a pivotal figure entered his life, Astilio Ricci, a mathematician and court engineer. Ricci was unlike the professors at the university. He did not demand blind obedience to tradition. He taught Galileo to observe, calculate, and question. He introduced him to the ancient works of Archimedes and Euclid, showing that numbers and geometry were not abstract concepts but the language of reality itself. Under Ricci's guidance, Galileo began seeing patterns in everything. Motion was no longer a mystery, it could be measured. Falling objects, swinging pendulums, rolling balls, all followed rules, predictable and observable. If only someone looked closely enough. Ricci encouraged Galileo to use mathematics, not just as a tool for calculation, but as a tool for understanding the universe. Galileo's fascination with mathematics grew so intense that he began neglecting his medical studies almost entirely. Lectures on anatomy and treatment bored him. Experiments with numbers and geometry thrilled him. While other students recited texts, he created diagrams, solved problems no one else dared attempt, and began designing small mechanical devices to test his ideas. In those days, universities were structured more as temples of tradition than laboratories of discovery. Professors were revered, and questioning their authority was considered audacious, even dangerous. Galileo, however, had inherited from his father a willingness to defy convention when evidence demanded it. Vincenzo had tested musical theory through experiments on strings. Galileo now tested nature itself, not merely accepting what Aristotle or Galen wrote centuries before. One memorable experiment during this period reflected his early genius. While walking through the Cathedral of Pisa, Galileo noticed a massive chandelier swinging above the marble floor. Most people ignored it, seeing only decoration. But Galileo observed carefully. He timed its swings, using the beat of his pulse. Slowly, methodically, he realized something remarkable. The time it took for each swing was almost independent of its amplitude. This simple observation planted the seeds for what would later become his laws of pendulum motion, fundamental to the understanding of time and mechanics. While other students studied fevers and bones, Galileo was learning the rules of the cosmos through careful observation and relentless questioning. During this period, Galileo's notebooks began to fill with sketches, calculations, and mechanical diagrams. He designed levers, pulleys, and inclined planes. He calculated the trajectory of rolling balls and experimented with pendulums. Every discovery, no matter how small, strengthened his belief that the universe was orderly and intelligible. Ritchie encouraged him to go further, to combine observation with mathematics, to trust what the world revealed rather than the words of ancient authorities. He introduced Galileo to the concept that nature operates according to laws that can be understood, described, and predicted. This approach was revolutionary at the time, as most scholars still relied heavily on philosophical reasoning divorced from experiment. As Galileo immersed himself in mathematics and physics, he began to form a distinct vision of the natural world. He no longer saw the Earth as a static center of the universe, a belief taught unquestioningly in both religion and science. Instead, he began to entertain ideas that were radical, controversial, and dangerous, that the planets moved, that the heavens were not immutable, that the cosmos could be measured and understood. Yet even as his mind reached for the stars, Galileo was still a young man, navigating the practical realities of life. He did not come from wealth. To support himself, he began tutoring students in mathematics. His reputation as a teacher grew, and with it came a sense of independence. He was no longer just a student. He was becoming a thinker, a problem solver, a pioneer. Galileo's choice to abandon medicine was bold. In Renaissance Italy, social status and financial security mattered deeply. By rejecting medicine for science, he risked alienating his family and society. But he was guided by a profound conviction. Knowledge and discovery mattered more than comfort or tradition. At this stage, Galileo also began connecting the disciplines of art, music, and science more deeply in his mind. He realized that mathematics was not just numbers on a page. It was harmony, proportion, and beauty. Musical vibrations, architectural balance, and celestial motion all followed the same principles. The universe was not random, which is a grand, elegant design waiting to be understood. By the end of this transformative period, Galileo had laid the foundation for the rest of his life. He had abandoned the safe, prescribed path of medicine. He had embraced mathematics and physics as tools to explore the universe. He had developed a mind trained to observe, question, and reason, a mind that would one day challenge centuries of dogma and reshape humanity's understanding of the cosmos. In the quiet corners of Pisa and Florence, young Galileo had begun the journey of a lifetime. The curious boy had become a determined scholar. The student of medicine had transformed into a seeker of truth. And though the world had yet to notice him, the universe was already preparing to reveal its secrets to Galileo Galilei. This was the man who would later peer through a telescope at Jupiter's moons, who would challenge the authority of the church, who would face house arrest and censorship and yet continue to write, think, and inspire generations. The first step had been taken. The path from medicine to science was complete. And the universe would never be the same. After leaving medicine behind, Galileo Galilei stepped into a new world, one where curiosity and observation would become his life's work. The streets of Pisa and Florence were alive with possibility for a mind like his. Renaissance Italy offered both beauty and knowledge. The music, art, and architecture that had surrounded him since childhood now intersected with his growing understanding of mathematics and physics. But Galileo's journey was far from easy. Without a degree or formal recognition, he needed a way to support himself. Teaching became his path. Galileo began working as a private tutor, sharing his knowledge of mathematics with students in aristocratic families. He taught geometry, arithmetic, and mechanics, demonstrating the elegance of numbers and the practical power of mathematics in daily life. For his pupils, he was patient and meticulous, showing not just formulas but the reasoning behind them. Yet teaching was not enough. Galileo's mind could not rest on the safety of the classroom. He was driven by a desire to explore, measure, and understand. At the time, most scholars still accepted the ideas of Aristotle, who had dominated scientific thought for nearly 2,000 years. Aristotle's teachings claimed, for example, that heavier objects fall faster than lighter ones. To the world, these were undeniable truths. To Galileo, they were challenges waiting to be tested. Galileo began conducting early experiments to understand motion and balance. He used inclined planes, pendulums, and rolling spheres to observe how objects moved. He meticulously recorded every result, looking for patterns. His notebooks filled with calculations, sketches, and diagrams. He measured angles, distances, and time, combining mathematical precision with careful observation. One of his most famous and often retold experiments involved the Leaning Tower of Pisa. While historical records debate the exact details, the story captures Galileo's method and determination. According to legend, he dropped two spheres of different weights from the tower to see how they fell. Aristotle had taught that heavier objects must fall faster than lighter ones. Galileo wanted proof. He wanted evidence. The results were astonishing. The two spheres hit the ground almost simultaneously. Galileo had demonstrated that falling speed did not depend on weight, challenging centuries of accepted wisdom. This simple but revolutionary observation marked the beginning of a lifetime of questioning authority and relying on experiment over dogma. Galileo's studies on motion did not stop at falling objects. He explored the laws of inertia, the principle that objects continue in motion unless acted upon by a force. He examined the behavior of pendulums, noticing the regularity and predictability of their swings. He began to see that the universe operated according to mathematical laws, precise and measurable, rather than the mystical principles often described by philosophers and theologians. Even as he conducted these experiments, Galileo faced challenges. Funding was scarce. Equipment was basic, and many colleagues were skeptical of his approach. Scholars preferred to discuss ideas in theory rather than test them in practice. Observation and experiment were often considered inferior to philosophical reasoning. Yet Galileo persevered. He built simple machines and devices to aid his studies, demonstrating ingenuity born from necessity. Teaching and experimentation became intertwined. Galileo's students often helped him with experiments, carrying materials, timing motions, or observing outcomes. Through teaching, Galileo refined not only his understanding but also his ability to communicate complex ideas clearly. He realized that science was not just discovery, it was explanation. To influence others, he needed to show them evidence, step by step, logically and convincingly. During this period, Galileo began formulating ideas that would later shake the foundation of science itself. He studied motion on inclined planes, calculating the acceleration of objects in ways that would eventually lead to the formulation of universal laws. He measured the behavior of pendulums and recognized that timing could be precise, leading to the first principles that would underpin accurate timekeeping. Galileo also became aware of a radical idea that was gaining traction, the heliocentric theory proposed by Copernicus. According to this theory, the Earth was not the center of the universe. Instead, it orbited the Sun along with the other planets. Most scholars and religious authorities dismissed or condemned this idea. Yet Galileo, armed with mathematics and observation, began to see its potential truth. His early experiments on motion and balance would later support this revolutionary view of the cosmos. It was not just the results of experiments that set Galileo apart, it was his method. He combined careful observation with mathematical reasoning, something few scholars of his time attempted. Where others relied on authority, Aristotle, or philosophical tradition, Galileo relied on nature itself as the teacher. Every rolling ball, every swinging pendulum, every object dropped from a height was a lesson, and Galileo was always listening. Galileo's approach began to attract attention. Patrons and scholars in Florence and Pisa noticed his talent. Some were intrigued by his brilliance. Others were wary of his willingness to challenge established ideas. He began to gain recognition, slowly at first, for both his teaching and experiments. Yet he remained humble, driven more by curiosity than fame. It was during this period that Galileo developed another crucial insight. The universe operates on universal laws, whether on Earth or in the heavens. Motion could be explained mathematically. This idea would later allow him to observe the moons of Jupiter and describe the movement of celestial bodies. But in these early years, he tested this principle on earthly objects, pendulums, balls, and inclined planes because they were accessible, measurable, and reliable. Galileo's experiments also illustrated a broader truth. Science is not a solitary pursuit. It is active, observable, and verifiable. Knowledge is not handed down from authority. It must be earned through effort, observation, and careful reasoning. By teaching and experimenting simultaneously, Galileo demonstrated that curiosity, rigor, and pedagogy can advance understanding in ways that books and lectures alone cannot. Despite the progress, Galileo faced challenges. Many traditional scholars dismissed his ideas. They saw motion as a philosophical concept, not a measurable reality. Experiments were often viewed as trivial, yet Galileo persisted. He continued to design experiments, refine his measurements, and develop theoretical insights. By the end of this phase of his life, Galileo was no longer simply a student or a tutor. He had become a pioneer of modern scientific thinking. His studies on motion and balance, His challenges to Aristotle's doctrines, and his combination of mathematics with observation laid the groundwork for everything he would later accomplish. These early experiments marked a turning point. Galileo had shown that the laws of nature could be discovered through reason and observation, rather than accepted authority. He had begun to see the universe not as a mystical, unchanging domain, but as a logical, predictable, and beautiful system. Little did he know that these small steps on the streets and rooftops of Pisa would lead him to the moons of Jupiter, the laws of falling bodies, and the revolutionary confirmation of the heliocentric theory. These experiments were the seeds of a legacy that would forever change how humanity sees the cosmos. Galileo had learned the first lesson of a lifetime. Truth is not dictated by tradition. It is revealed through careful observation, daring experiments, and fearless questioning. This lesson would guide him through controversy, censorship, and the trials of the church. But for now, he was still young, eager, and full of curiosity, ready to let the world show him its secrets. One experiment at a time. The first sparks of a revolutionary mind had ignited. The student had become a teacher. The observer had become a thinker. And the universe was about to reveal more than anyone could imagine. In 1592, a new chapter opened in Galileo Galilei's life. He left the familiar streets of Pisa and Florence behind and traveled to Padua, a bustling city in northern Italy, known for its university, vibrant culture, and freedom of thought. At the age of 28, Galileo had already gained a reputation as a brilliant mathematician and thinker, but the years ahead in Padua would mark the happiest and most productive period of his life. Padua was a city alive with ideas. Its university attracted scholars from across Europe. Unlike Pisa, where tradition often weighed heavily on students, Padua encouraged independent thinking. Professors debated ideas openly. Students experimented freely. The city itself was a center of Renaissance learning, filled with libraries, theaters, and churches adorned with breathtaking art. To a curious mind like Galileo's, it was a paradise. Galileo was offered a position as professor of mathematics at the University of Padua, a prestigious role with a secure salary. Finally, he could teach, experiment, and explore without constantly worrying about financial survival. He moved into a comfortable home, which became a haven of learning, creativity, and family life. It was in Padua that Galileo truly experienced personal happiness. He married and started a family, raising children in an environment filled with curiosity and music, much like the household of his own youth. He loved his family deeply, and despite his later struggles with the church, these years were a rare period of peace and contentment. Padua allowed him to balance personal life with professional achievement, a combination that would become increasingly rare as his fame and controversy grew. Academically, these were incredibly productive years. Galileo immersed himself in the study of motion, gravity, and mechanics, the areas that had fascinated him since his early experiments in Pisa. He refined the principles he had begun observing on inclined planes and swinging pendulums. Every experiment, every measurement, was carefully recorded. He sought patterns, general rules, and the mathematical laws underlying nature. One of Galileo's most remarkable contributions during this period was his work on the laws of falling bodies, using inclined planes to slow the motion of rolling balls. He could measure the acceleration of objects with unprecedented precision. Through careful observation in mathematics, he discovered that all objects, regardless of weight, fall at the same rate in a vacuum, a principle that would later become a cornerstone of physics. This challenged centuries of Aristotelian teaching, which claimed that heavier objects fall faster than lighter ones. But Galileo's work in Padua was not limited to falling bodies. He studied projectiles, levers, pulleys, and the mechanics of motion. He explored the idea that motion was not chaotic, but could be described through mathematical laws. The tools of observation, calculation, and experiment became central to his method, which would later define modern science. While working in mechanics, Galileo also wrote some of his first significant scientific books. These were not dry academic treatises, but clear, precise works designed to teach and inspire. He explained principles through experiments that anyone could replicate. His writing demonstrated not just his intellect but his ability to communicate complex ideas in a way that made sense to others. One of his early books described the mechanics of motion and the mathematics behind it, laying the foundation for his later, more famous works. Galileo's life in Padua was also marked by his growing popularity among students. He was a teacher who inspired curiosity rather than rote memorization. He encouraged his pupils to experiment, question, and observe, instilling in them the same methods that had guided his own discoveries. Students often crowded into his lectures, fascinated by demonstrations of motion, gravity, and the strange behaviors of objects in the physical world. It was a time of freedom and exploration. In Padua, Galileo could experiment without the fear of censorship that would later accompany his work in Florence and Rome. He could travel, correspond with other scholars across Europe, and continue expanding his knowledge. He often worked late into the night, sketching diagrams, making calculations, and imagining the universe as a system of orderly laws. all while listening to the sounds of his children playing or the distant music of the city streets. This period also allowed him to blend his love of art, music, and science. Galileo saw the world as a unified whole, where mathematics could explain both beauty and motion. The balance of music, the symmetry of architecture, and the precision of physical laws were not separate realms, they were all interconnected. Padua offered him the environment to explore these connections fully, without interference. During his years in Padua, Galileo also became known for his practical inventions and mechanical devices. He built compasses, clocks, and tools for measuring motion. These inventions demonstrated his genius not only as a theorist, but also as an engineer and problem solver. He experimented with levers and pulleys, using mathematics to describe how forces and motion interacted. Every device he built was a step toward understanding the larger universe. Yet even in this period of happiness, there were seeds of future conflict. Galileo's ideas were radical, challenging long-standing Aristotelian physics. While Padua provided a tolerant environment, he knew that his work would eventually clash with more conservative forces in the church and academia. He quietly nurtured these discoveries, building a body of work that would later make him famous and infamous. Personal life, teaching, and scientific work were intricately connected in Padua. Galileo's home was filled with laughter, music, and discussion, mirroring the stimulating environment of his own childhood. He enjoyed time with his children and students alike, encouraging curiosity and observation. He even began corresponding with other scholars in Italy and beyond, exchanging ideas and discoveries. Padua was, in many ways, the peak of Galileo's early life. Here, he experienced personal joy, academic freedom, and intellectual flourishing. It was a period where he could experiment boldly, write clearly, and teach passionately, all while raising a family he loved. These years shaped the man who would later challenge the heavens themselves. In this city, Galileo began to see the universe as a coherent, measurable system. Motion, gravity, balance, and mechanics were no longer mysteries, they were rules waiting to be discovered. Every rolling ball, swinging pendulum, and lever he tested brought him closer to the realization that the universe could be understood mathematically. And it was in Padua that Galileo began to prepare for his greatest discoveries. The telescope, the moons of Jupiter, and his revolutionary support for the heliocentric theory were still on the horizon. But the foundation for these breakthroughs, the method of observation, experiment, and mathematics was fully established. For Galileo, Padua was not just a city. It was a laboratory, a classroom, and a home. It was where his mind thrived, where his family grew, and where the first seeds of modern science truly took root. These years were peaceful, productive, and joyful, yet they also carried the quiet tension of what was to come. Because the universe he was beginning to understand would one day bring him into conflict with the most powerful institutions in Europe. But for now, Galileo was content. He was a teacher, a father, an experimenter, and a thinker. He was living fully in the freedom Padua allowed, discovering, learning, and observing. Ready for the extraordinary revelations that awaited him in the years ahead. Padua gave him happiness, security, and intellectual freedom, but it also gave him the courage, skill, and method that would eventually change humanity's understanding of the cosmos forever. By the early 1600s, Galileo Galilei had spent years observing, experimenting, and teaching. His work on motion, gravity, and mechanics had already set him apart as one of the most brilliant minds of his time. But Galileo was not content with understanding only what happened on Earth. He longed to look beyond the familiar skies, to explore the heavens themselves. It was in this period that Galileo began to experiment with a device that would change his life and the world forever, the telescope. At that time, telescopes were crude instruments, simple tubes with lenses. They could magnify objects slightly, but offered a blurry and limited view of distant things. Most scholars did not see much value in them. They were considered toys or curiosities, not serious tools for science. But Galileo had a vision. He believed that with careful construction and refinement, a telescope could reveal the universe in ways no one had ever imagined. Galileo spent months building and perfecting his instruments. He experimented with lenses, angles, and focal lengths, meticulously adjusting every detail. Finally, in 1609, he had a telescope capable of magnifying objects 20 times. With this new eye on the sky, Galileo began to observe the heavens, and what he saw astounded him. The first celestial body to capture his attention was the moon. To the naked eye, the moon had always appeared smooth and perfect, a flawless sphere in the night sky. Aristotelian teaching claimed the heavens were perfect and unchanging. But Galileo's telescope revealed a very different reality. Through the lens, he saw mountains, valleys, and craters, evidence of a rugged, uneven surface. Shadows cast by the peaks of mountains stretched across the lunar plains, proving that the moon was not a perfect, smooth orb, but a world in itself, filled with landscapes and terrain, similar in some ways to Earth. This discovery shook the prevailing belief that the heavens were flawless and unalterable, but the moon was only the beginning. Galileo's curiosity pushed him to scan the skies more broadly. One night, while observing the planet Jupiter, he noticed for small points of light near the giant planet. Night after night, he returned to observe them, carefully charting their positions. He realized that these points were not fixed stars, they orbited Jupiter. Galileo had discovered the 4 largest moons of Jupiter, which he later named Io, Europa, Ganymede, and Callisto. This was a revelation of immense significance. For the first time, it was evident that not everything revolved around the Earth. Here was a clear demonstration that celestial bodies could orbit other planets, providing strong evidence for the heliocentric model proposed by Copernicus. Every night, Galileo charted the movements of these moons, recording their positions with painstaking accuracy. He understood the implications. The universe was not centered on humanity, as the Church had long taught. Instead, it was a dynamic system, governed by laws that could be observed, measured, and understood. Galileo also observed the phases of Venus, further supporting the heliocentric theory. Venus went through a complete set of phases, similar to the Moon, which could only be explained if it orbited the Sun. Each observation, each measurement, was a piece of evidence challenging centuries of established belief. But perhaps most revolutionary of all was the method Galileo used. He did not rely on argument or tradition. He relied on observation, measurement, and careful documentation. He used mathematics to describe motion, geometry to describe orbits, and repeated observations to ensure accuracy. Science, for the first time, was becoming a tool for truth rather than speculation. These discoveries brought Galileo fame but also danger. The Church had long taught that the Earth was the center of the universe. The Sun, stars, and planets were supposed to revolve around it. Galileo's observations directly challenged this worldview. Already, he had begun to attract both admirers and skeptics, scientists and theologians. In private, Galileo was thrilled by his findings. He could see the mountains on the Moon, the moons of Jupiter, the phases of Venus, and countless stars previously invisible to the naked eye. He marveled at the complexity and order of the cosmos. For him, these discoveries were not merely scientific, they were deeply emotional and spiritual experiences. The universe, vast and intricate, revealed its secrets to those who dared to look and measure. Galileo also began writing about his observations, producing works that explained the evidence and presented it logically. He combined detailed sketches, measurements, and clear reasoning, making it accessible to scholars and educated readers alike. His books spread quickly, igniting excitement and debate across Europe. Scholars marveled, students were inspired, and the public glimpsed a universe far larger and stranger than they had ever imagined. Through these discoveries, Galileo fundamentally changed astronomy forever. The Moon was no longer a perfect celestial sphere. Jupiter had its own orbiting moons. Venus had phases, proving its orbit around the Sun. The Earth was no longer the fixed center of the cosmos. All of these observations collectively overturned centuries of assumptions. Galileo's work in this period marked a turning point, not just in astronomy but in human thought. He demonstrated that the universe could be studied, measured, and understood, using observation and reason rather than reliance on authority or tradition. His telescope became a symbol of human curiosity, courage, and the power of careful, systematic investigation. These nights spent staring at the stars were among the happiest and most productive of Galileo's life. In the quiet of Padua and later Florence, he meticulously documented his findings, shared them with colleagues, and continued experimenting with lenses to see further and clearer. The sky had become his laboratory, and the universe his teacher. Yet even in this triumph, the seeds of conflict were already forming. Galileo knew that his discoveries challenged the deeply entrenched beliefs of the Church and the academic establishment. He understood that observation and evidence might clash with centuries of authority, and that defending truth would require courage, diplomacy, and persistence. But for now, Galileo was lost in wonder. He observed the mountains on the Moon, traced the orbits of Jupiter's moons, and watched Venus transition through its phases. Every night, he saw evidence that the cosmos was dynamic, measurable, and governed by laws. And with every observation, he grew more certain that the universe was far more beautiful, complex, and ordered than anyone had imagined. The telescope had opened his eyes to the heavens. It had revealed worlds within worlds, moons orbiting planets, and mysteries waiting to be discovered. Galileo had not only looked at the stars, he had changed the way humanity looked at them. And in that moment, Galileo Galilei, the boy from Pisa who once wondered about falling objects, had become the father of modern observational astronomy. The universe would never be the same again. By the early 1600s, Galileo Galilei had spent years observing, experimenting, and teaching. His work on motion, gravity, and mechanics had already set him apart as one of the most brilliant minds of his time. But Galileo was not content with understanding only what happened on Earth. He longed to look beyond the familiar skies, to explore the heavens themselves. It was in this period that Galileo began to experiment with a device that would change his life and the world forever, the telescope. At that time, telescopes were crude instruments, simple tubes with lenses. They could magnify objects slightly, but offered a blurry and limited view of distant things. Most scholars did not see much value in them. They were considered toys or curiosities, not serious tools for science. But Galileo had a vision. He believed that with careful construction and refinement, a telescope could reveal the universe in ways no one had ever imagined. Galileo spent months building and perfecting his instruments. He experimented with lenses, angles, and focal lengths, meticulously adjusting every detail. Finally, in 1609, he had a telescope capable of magnifying objects 20 times. With this new eye on the sky, Galileo began to observe the heavens, and what he saw astounded him. The first celestial body to capture his attention was the moon. To the naked eye, the moon had always appeared smooth and perfect, a flawless sphere in the night sky. Aristotelian teaching claimed the heavens were perfect and unchanging. But Galileo's telescope revealed a very different reality. Through the lens, he saw mountains, valleys, and craters, evidence of a rugged, uneven surface. Shadows cast by the peaks of mountains stretched across the lunar plains, proving that the moon was not a perfect, smooth orb, but a world in itself, filled with landscapes and terrain, similar in some ways to Earth. This discovery shook the prevailing belief that the heavens were flawless and unalterable, but the moon was only the beginning. Galileo's curiosity pushed him to scan the skies more broadly. One night, while observing the planet Jupiter, he noticed for small points of light near the giant planet. Night after night, he returned to observe them, carefully charting their positions. He realized that these points were not fixed stars, they orbited Jupiter. Galileo had discovered the 4 largest moons of Jupiter, which he later named Io, Europa, Ganymede, and Callisto. This was a revelation of immense significance. For the first time, it was evident that not everything revolved around the Earth. Here was a clear demonstration that celestial bodies could orbit other planets, providing strong evidence for the heliocentric model proposed by Copernicus. Every night, Galileo charted the movements of these moons, recording their positions with painstaking accuracy. He understood the implications. The universe was not centered on humanity, as the Church had long taught. Instead, it was a dynamic system, governed by laws that could be observed, measured, and understood. Galileo also observed the phases of Venus, further supporting the heliocentric theory. Venus went through a complete set of phases, similar to the moon, which could only be explained if it orbited the sun. Each observation, each measurement, was a piece of evidence challenging centuries of established belief. But perhaps most revolutionary of all was the method Galileo used. He did not rely on argument or tradition. He relied on observation, measurement, and careful documentation. He used mathematics to describe motion, geometry to describe orbits, and repeated observations to ensure accuracy. Science, for the first time, was becoming a tool for truth rather than speculation. These discoveries brought Galileo fame but also danger. The Church had long taught that the Earth was the center of the universe. The sun, stars, and planets were supposed to revolve around it. Galileo's observations directly challenged this worldview. Already, he had begun to attract both admirers and skeptics, scientists and theologians. In private, Galileo was thrilled by his findings. He could see the mountains on the moon, the moons of Jupiter, the phases of Venus, and countless stars previously invisible to the naked eye. He marveled at the complexity and order of the cosmos. For him, these discoveries were not merely scientific, they were deeply emotional and spiritual experiences. The universe, vast and intricate, revealed its secrets to those who dared to look and measure. Galileo also began writing about his observations, producing works that explained the evidence and presented it logically. He combined detailed sketches, measurements, and clear reasoning, making it accessible to scholars and educated readers alike. His books spread quickly, igniting excitement and debate across Europe. Scholars marveled, students were inspired, and the public glimpsed a universe far larger and stranger than they had ever imagined. Through these discoveries, Galileo fundamentally changed astronomy forever. The moon was no longer a perfect celestial sphere. Jupiter had its own orbiting moons. Venus had phases, proving its orbit around the sun. The Earth was no longer the fixed center of the cosmos. All of these observations collectively overturned centuries of assumptions. Galileo's work in this period marked a turning point, not just in astronomy but in human thought. He demonstrated that the universe could be studied, measured, and understood, using observation and reason rather than reliance on authority or tradition. His telescope became a symbol of human curiosity, courage, and the power of careful, systematic investigation. These nights spent staring at the stars were among the happiest and most productive of Galileo's life. In the quiet of Padua and later Florence, he meticulously documented his findings, shared them with colleagues, and continued experimenting with lenses to see further and clearer. The sky had become his laboratory, and the universe his teacher. Yet even in this triumph, the seeds of conflict were already forming. Galileo knew that his discoveries challenged the deeply entrenched beliefs of the Church and the academic establishment. He understood that observation and evidence might clash with centuries of authority. and that defending truth would require courage, diplomacy, and persistence. But for now, Galileo was lost in wonder. He observed the mountains on the moon, traced the orbits of Jupiter's moons, and watched Venus transition through its phases. Every night, he saw evidence that the cosmos was dynamic, measurable, and governed by laws, and with every observation, he grew more certain that the universe was far more beautiful, complex, and ordered than anyone had imagined. The telescope had opened his eyes to the heavens. It had revealed worlds within worlds, moons orbiting planets, and mysteries waiting to be discovered. Galileo had not only looked at the stars, he had changed the way humanity looked at them. And in that moment, Galileo Galilei, the boy from Pisa who once wondered about falling objects, had become the father of modern observational astronomy. The universe would never be the same again. By the mid-1610s, Galileo Galilei had achieved fame, recognition, and influence across Europe. He had observed the heavens, discovered the moons of Jupiter, studied motion, and challenged centuries of accepted wisdom. His telescope had revealed a universe far more complex and dynamic than anyone had imagined. Yet as Galileo's star rose, a shadow began to form, one that would challenge not just his discoveries, but his very freedom to speak the truth. The source of this shadow was the Church. In Galileo's time, the Catholic Church held immense authority not only over spiritual matters, but also over the interpretation of the natural world. Scripture and tradition were considered the ultimate guides to truth, and any idea that contradicted these teachings was dangerous, even heretical. Galileo, however, was a man of reason. He believed that observation, mathematics, and experiment were the proper tools for understanding the universe, and he believed that science and faith could coexist, if properly separated. For him, the Bible taught spiritual and moral truths, guiding humanity's soul. The natural world, on the other hand, followed laws discoverable by careful study. Science, he argued, should describe nature, not dictate theology. Galileo's support for the heliocentric model, proposed by Copernicus decades earlier, was at the center of this emerging conflict. Copernicus had suggested that the sun, not the earth, was at the center of the universe. Planets including Earth revolved around it. To many scholars, this was an elegant mathematical model, but to the Church, it appeared to contradict Scripture. Passages suggesting that the earth was fixed and immovable were cited as undeniable truth. Galileo recognized the danger of this divide. He wrote letters and treatises emphasizing that the Bible should not be read as a science textbook. The purpose of Scripture, he argued, was to teach people how to live virtuous lives, not how the planets moved. Nature had its own laws, accessible through reason and observation, independent of theology. These writings were revolutionary and risky. Galileo was treading a fine line between innovation and heresy. In private correspondence, he carefully explained his reasoning, showing respect for the Church while also asserting the independence of scientific truth. He sought a way to advance knowledge without directly confronting religious authority. Despite his caution, Galileo's ideas could not remain hidden. In 1616, the Church issued its first official warning. The Inquisition, concerned with the spread of the heliocentric theory, formally told Galileo that he could no longer advocate or teach that the Earth moved around the Sun. He was ordered to stay silent on heliocentrism, under threat of censure. For Galileo, this was a devastating blow. His discoveries were not hypothetical. They were observed facts, measurable, and repeatable. To be forced into silence was both intellectually and personally painful. Yet Galileo was strategic. He complied outwardly, carefully framing his work to avoid direct confrontation, while continuing to study, write, and think. During this period, he also faced growing skepticism from other scholars. Many Aristotelian thinkers remained committed to the old geocentric model, arguing that centuries of tradition could not be wrong. Some accused Galileo of arrogance, suggesting that his telescopic observations were illusions or misinterpretations. Others feared the social and religious consequences of challenging established doctrine. Despite these pressures, Galileo continued to explore the heavens. He refined his telescopes, made new observations, and wrote extensively on mechanics and motion. He also began mentoring a new generation of scientists, teaching them to observe carefully, question boldly, and rely on evidence rather than authority. In doing so, he was quietly preparing for the moment when he could speak openly again. Galileo's correspondence during these years reveals his intellectual courage. He maintained that science and Scripture were separate domains, each with its own authority. He argued that interpreting the natural world required different methods than interpreting religious texts. By emphasizing this separation, he hoped to defend scientific inquiry without directly attacking faith, a delicate and often dangerous balancing act. Yet the Church's restrictions weighed heavily on him. The order to remain silent was not merely an academic inconvenience. It was a form of censorship. Galileo was prevented from teaching or publishing ideas that he knew to be true. He felt the tension keenly. The universe itself seemed to cry out its secrets, yet he was forbidden to share them fully. During this period, Galileo also witnessed the reactions of his peers and patrons. Many were amazed by his discoveries but hesitant to support him openly, fearing the church's wrath. Even the Medici family, while protective, could not shield him entirely from religious scrutiny. Galileo had to navigate a complex web of politics, patronage, and ideology, balancing truth with safety. Despite these challenges, Galileo's determination did not falter. He continued to refine his methods, document his observations, and write cautiously about the implications of heliocentrism. He developed ways to present his findings as hypothetical or mathematical models, rather than as direct challenges to scripture. This careful framing allowed him to keep advancing knowledge, even under threat. Galileo's situation highlights a profound historical tension: the conflict between empirical evidence and established authority. He lived in an era when challenging accepted wisdom could lead to censure, exile, or even execution. Yet he persisted, demonstrating that the pursuit of truth often requires courage, patience, and careful strategy. This period also reveals Galileo's human side. He was frustrated, anxious, and aware of the personal risks of his work. He loved his family, valued his students, and respected tradition, yet he could not ignore the facts he observed. He experienced the emotional strain of living under warning, knowing that speaking freely could lead to serious consequences. Yet he also felt the exhilaration of discovery, the joy of seeing the universe reveal its structure and patterns. The first warning in 1616 was only the beginning. It marked the start of Galileo's long struggle with the church, a struggle that would define the later part of his life. He was forced to confront questions that were both scientific and moral. How far could he pursue knowledge without endangering himself or his family? How could he defend evidence-based science in a world dominated by religious authority? Galileo's approach during this time set a precedent for the future of science. He demonstrated that evidence could challenge dogma, but also that persuasion, strategy, and careful argumentation were necessary to navigate the social and political realities of the day. He laid the foundation for a separation between science and religious doctrine that would influence centuries of intellectual thought. Even under restriction, Galileo continued to inspire others. His students carried forward his methods. His writings, carefully framed, circulated among scholars. The telescope, his observations, and the principles of heliocentrism remained alive in the scientific community, waiting for the moment when they could be discussed openly. In private, Galileo never stopped believing in the truths he had observed. He saw a universe governed by laws, measurable and predictable, and he knew that one day, evidence would prevail over tradition. For him, science was not just a career, it was a moral and intellectual duty. The pursuit of knowledge required persistence, courage, and integrity. By the end of this period, Galileo had learned a harsh lesson: truth can be dangerous. Yet he also learned how to survive, adapt, and continue pursuing discovery. He had been forced to silence himself on heliocentrism, but he did not abandon his observations. He refined them, documented them, and waited for a time when he could present them in full. This chapter of Galileo's life, marked by warning, restriction, and intellectual tension, demonstrates the courage required to pursue knowledge in a world where ideas could threaten authority. It is a story not just of conflict, but of resilience, a man standing between evidence and dogma, refusing to ignore what he could see, yet navigating the dangers of the society around him. Galileo's experiences in these years set the stage for his later works, including the dialogue concerning the two chief world systems, which would finally bring his ideas to a wider audience and to the center of the church's scrutiny. His determination to separate science from religion and to pursue truth even under threat would inspire generations of thinkers who followed. Though forced into silence, Galileo continued to observe, calculate, and reflect. He kept his notebooks filled with data. He watched the heavens, measured the motions of celestial bodies, and refined his understanding of mechanics and motion. Each observation was a silent act of defiance, a testament to his belief that the universe could be understood, even if society demanded silence. In the struggle between science and religion, Galileo became a symbol of intellectual courage. He showed that curiosity and observation could challenge centuries of accepted authority, and that the pursuit of truth often requires both bravery and patience. His work during this period reminds us that discovery is not always safe, and truth is not always popular, but its impact can change humanity forever. Galileo had been warned, he had been silenced, but he had not been defeated. The stage was set for the next act, a confrontation that would test his courage, his intellect, and his faith in the power of reason. By the early 1630s, Galileo Galilei had spent decades observing, experimenting, teaching, and thinking. He had transformed human understanding of motion, mechanics, and the heavens. His discoveries, the mountains on the moon, the moons of Jupiter, the phases of Venus had already shaken the foundations of astronomy. Yet Galileo's most daring challenge to authority was still ahead, a book that would place him at the center of one of history's most dramatic confrontations between science and religion. Galileo knew that he could no longer remain silent about heliocentrism, the sun-centered system proposed by Copernicus, which he had long observed and confirmed. The church had already warned him in 1616 not to teach or advocate for this model, but decades of study, careful observation, and the accumulation of evidence had convinced him beyond doubt. The Earth was not the center of the universe. The sun, planets, and stars moved according to predictable laws, and Galileo had the measurements, drawings, and calculations to prove it. In 1632, he published Dialogue Concerning the Two Chief World Systems, a masterful work that presented the arguments for both the Earth-centered geocentric system and the sun-centered heliocentric system. But Galileo was not merely reporting ideas. He was crafting a narrative, a dialogue between three fictional characters, each representing different points of view. Through lively conversation, humor, and clever reasoning, he explained the scientific evidence in a way that was accessible, persuasive, and difficult to ignore. The book was brilliantly written. One character, Simplicio, represented the traditional Aristotelian view and defended the geocentric system. Another, Salviati, voiced Galileo's ideas, explaining observations and evidence supporting heliocentrism. The third, Sagredo, served as an intelligent observer, asking questions, weighing arguments, and ultimately guiding the reader to see the logic of the sun-centered model. Through this dialogue, Galileo achieved something extraordinary. He educated, persuaded, and challenged simultaneously. Readers could follow the conversation, understand the evidence, and engage with the ideas themselves. The book was scientific, philosophical, and literary all at once, a perfect blend of observation, reasoning, and storytelling. But it was also daring, perhaps dangerously so. Simplicio, the character representing the church's traditional stance, was portrayed as slow, simplistic, and easily refuted. Many church leaders recognized themselves in his arguments, and they were not pleased. Galileo had not just presented heliocentrism as an idea, he had mocked its critics, all while presenting undeniable evidence for the sun-centered system. The reaction was swift. Within months, copies of the dialogue spread across Italy and Europe, attracting both admiration and outrage. Scholars marveled at the clarity and elegance of Galileo's reasoning, while powerful church officials bristled at what they saw as a challenge to authority and doctrine. The Inquisition, already wary of his influence, began to scrutinize the book closely. Galileo, aware of the risks, had attempted to frame the work carefully. He argued that the dialogue presented arguments rather than declaring doctrine outright. He emphasized that heliocentrism was a scientific model, supported by observation and reason, rather than a theological assertion. But the church saw the book differently. To them, Galileo had crossed a line, appearing to advocate a system they considered contrary to Scripture. The publication of the dialogue quickly led to accusations of heresy. Galileo was summoned to Rome in 1633 to defend his work before the Inquisition. This was no ordinary academic debate. He faced powerful cardinals and theologians, men with authority over the fate of scholars, the interpretation of Scripture, and the enforcement of church law. The trial would be a test of not just intellect, but courage, diplomacy, and personal resolve. Before the trial, Galileo must have reflected on his life, the long years of teaching, observing, and experimenting, the quiet nights spent staring at the stars, the meticulous recording of every measurement. He knew the evidence was on his side, yet he also understood the danger he faced. Speaking the truth in the wrong way could lead to imprisonment, loss of freedom, or worse. The trial itself was tense and dramatic. Church officials demanded that Galileo recant his support for heliocentrism, arguing that Scripture clearly taught the Earth's immobility. Galileo tried to defend the scientific method, stressing observation, mathematics, and evidence. He explained that understanding the universe through reason and experiment did not diminish faith. Rather, it revealed the grandeur of God's creation in ways that Scripture described in spiritual, not literal, terms. Despite his eloquence, the Inquisition was unmoved. The Church viewed Galileo's dialogue as a direct challenge to authority, an act of defiance disguised as inquiry. In the end, Galileo was forced to recant publicly, acknowledging that heliocentrism was formally contrary to Scripture. He swore that he would never again hold, teach, or defend the sun-centered model. The moment was crushing. Galileo, once the celebrated teacher, observer, and advisor to princes, now faced humiliation, restriction, and the weight of institutional power. Yet even in this dark hour, his mind remained alive. Historical accounts suggest that as he recited his recantation, he whispered a phrase that has become legendary: "E per se move," and yet it moves. Whether he actually said it or not, it symbolized his unshakable belief in truth, in evidence, and in the universe itself. After the trial, Galileo was sentenced to house arrest for the remainder of his life. He was prohibited from publishing any works advocating heliocentrism for a man whose life had been devoted to exploration, observation, and discovery. This was a bitter punishment. Yet he continued to study, write, and think in private. Even confined to his home, Galileo's curiosity could not be extinguished. During house arrest, Galileo produced some of his most important scientific work. He wrote on motion, mechanics, and mathematical principles. refining theories that would influence generations of scientists. He continued to correspond with colleagues and students, sharing ideas cautiously. Though silenced publicly, his intellectual legacy continued to grow. The publication of the dialogue and the subsequent trial highlight a profound historical tension: the struggle between evidence-based science and institutional authority. Galileo's brilliance lay not only in his discoveries but in his insistence that nature could be understood through observation, mathematics, and reason, even when such truths were inconvenient or dangerous. Galileo's experience also illustrates the human dimension of scientific pursuit. He was a man of curiosity, courage, and passion, but also vulnerable, aware of the risks, and deeply affected by the judgment of powerful authorities. His conflict was not just intellectual, it was personal, emotional, and moral. He had devoted his life to truth, yet the world was not ready to accept it fully. Despite the trial and condemnation, Galileo's influence continued to expand. His dialogue circulated in manuscript copies and among scholars who read it privately, keeping the ideas of heliocentrism alive. His methods, careful observation, meticulous recording, and the use of mathematics to describe nature became the foundation of modern science. In the long view of history, the Church's attempt to silence him could not suppress the truth he had uncovered. Galileo's story in this chapter is a reminder that truth and discovery often face resistance. He had dared to challenge centuries of accepted belief, to present evidence that contradicted authority, and to argue for a separation between observation and dogma. The cost was high: public recantation, restriction, and the threat of punishment. Yet the reward: humanity's understanding of the cosmos was immeasurable. The dialogue on two world systems remains one of the most significant works in the history of science. It is not merely a book. It is a symbol of courage, intellect, and the enduring power of evidence. Galileo's ability to combine storytelling, reason, and observation created a work that could educate, persuade, and inspire, even under the threat of institutional suppression. In the end, Chapter 8 of Galileo's life demonstrates that the pursuit of knowledge is rarely easy. It requires courage, integrity, and resilience. Galileo faced the full force of religious authority, yet he continued to believe in what he had observed, to record his findings, and to inspire future generations. The universe, he understood, would not be silenced. Even in confinement, Galileo remained the same curious, fearless mind who had dropped spheres from the Leaning Tower of Pisa, built telescopes, and mapped the heavens. He had challenged tradition, faced censure, and endured restriction, but his discoveries, his methods, and his courage ensured that he would live on in history as the father of modern science, a man who trusted evidence above all, even when the world demanded silence. Galileo's dialogue was more than a book. It was a statement. The universe moves, and truth cannot be denied, even when human authority attempts to suppress it. His struggle was the struggle of science itself, a battle to observe, to measure, and to understand, in the face of fear, dogma, and opposition. The Great Debate book marked the climax of Galileo's public conflict with the Church, a chapter filled with intellect, courage, strategy, and consequence. It set the stage for his final years, where, confined but undeterred, he continued to advance knowledge, refine theories, and leave a legacy that would outlive both his enemies and his own mortal life. Galileo had written, argued, and endured. He had faced the ultimate challenge to his ideas and survived, leaving behind a message that would resonate for centuries. Truth is discovered, not decreed. Observation is powerful, and the universe belongs to all who dare to see it clearly. By the spring of 1633, the brilliant, fearless, and inquisitive mind of Galileo Galilei stood at the center of a storm unlike any he had ever faced. For decades he had observed the heavens, measured the motion of objects on Earth, and challenged the very foundations of Aristotelian science. Through telescopes of his own making, he had unveiled mountains on the moon, moons orbiting Jupiter, and the phases of Venus, evidence that the Earth was not the fixed center of the universe. Yet now, all of this knowledge, all of his careful reasoning, would collide head-on with the might of the Roman Catholic Church. Galileo's crime, in the eyes of the Inquisition, was clear. He had supported heliocentrism, the sun-centered model of the universe, which contradicted centuries of accepted teaching. The Church had warned him in 1616 to remain silent on the matter, yet over a decade later, Galileo had published the dialogue concerning the two chief world systems, a carefully crafted work that not only explained the heliocentric theory, but did so in a way that made the geocentric defenders appear foolish. Too powerful Church officials, Galileo had gone too far. He had publicly challenged authority, and now he would face the consequences. Galileo was summoned to Rome, traveling under the shadow of both fame and fear. He was no stranger to scrutiny, having navigated the academic and political worlds of Florence and Padua, but the Inquisition was a force unlike any he had encountered. It wielded the power to silence, punish, or even destroy those deemed heretical. For a man devoted to reason, evidence, and truth, this confrontation was deeply perilous. Upon arrival, Galileo was subjected to intense questioning. The Inquisition sought not merely his explanations but his compliance. He was pressured to renounce publicly his support for the heliocentric system, to admit that he had been mistaken, and to acknowledge the Church's authority over interpretation of Scripture. Threats of torture loomed over him. Though he was a man of advanced age and declining health, the Church made clear that disobedience could have deadly consequences. The trial was as much a psychological battle as it was a legal proceeding. Church officials debated Galileo's guilt and influence, discussing the theological implications of his work. Scholars and theologians argued that allowing heliocentrism to flourish could undermine not only Scripture, but the Church's authority itself. Each question, each argument, tested Galileo's courage, wit, and ability to navigate a perilous landscape. Galileo was forced to confront a devastating reality. The pursuit of truth could carry immense personal cost. He had spent a lifetime observing, measuring, and thinking, yet here he was, under threat of punishment for daring to speak what he had seen with his own eyes. The evidence he had gathered: the mountains of the moon, Jupiter's moons, the phases of Venus, was undeniable. But in a society where authority held more weight than observation, Galileo had to tread carefully. Ultimately, the Inquisition demanded that Galileo formally recant. On April 12, 1633, in a tense and somber ceremony, Galileo publicly denied the heliocentric system. He swore, on his honor and faith, that he would never again defend or teach that the earth moved around the sun. This moment was both humiliating and heartbreaking. A man who had devoted his life to observing the truth was forced to deny what he knew to be reality. Yet despite the recantation, the Church could not ignore the threat his mind still represented. Galileo was sentenced to house arrest for the remainder of his life. He would no longer teach publicly, publish works that challenged doctrine, or freely share his observations. His intellectual freedom was curtailed. The brilliant scientist who had mapped the moons of Jupiter would be confined to a home, barred from the public sphere he had once dominated. Galileo's sentence was severe, yet it could have been worse. The Inquisition's power was absolute. He could have faced imprisonment in harsher conditions, or even execution for heresy. House arrest, though restrictive, allowed him to continue thinking, observing, and writing in private, preserving the core of his intellectual life. The emotional toll of the trial was immense. Historical accounts suggest that Galileo endured the process with dignity, but also with deep sorrow and frustration. The humiliation of public recantation, the weight of institutional judgment, and the isolation imposed by house arrest were bitter for a man whose curiosity and intellect had always driven him outward, toward discovery. For someone who had once observed the cosmos in all its freedom and beauty, confinement must have felt like a cruel irony. Yet even in these dark circumstances, Galileo's mind remained active. House arrest did not silence his curiosity. He continued to write, to calculate, and to refine his theories. He explored motion, mechanics, and mathematics, producing works that would influence generations long after his death. The Inquisition had restricted his voice, but it could not extinguish his intellect. The trial also serves as a vivid example of the conflict between authority and evidence. Galileo's experiences illustrate how revolutionary ideas often collide with entrenched systems of power. His observations were precise, repeatable, and undeniable. Yet human institutions were not always ready or willing to accept evidence that contradicted long-held beliefs. In this sense, Galileo's story is not only about science, but also about courage, resilience, and the pursuit of truth in the face of oppression. Even in isolation, Galileo continued to mentor students and correspond with fellow scientists. He shared ideas through letters, advised colleagues, and refined his methods, ensuring that the principles he had established, the importance of observation, experiment, and mathematics, remained alive. His physical confinement could not stop the spread of his influence, and his work would eventually help shape the foundations of modern physics and astronomy. House arrest also offered Galileo time for reflection. Removed from the pressures of public scrutiny, he could contemplate the cosmos, the laws of motion, and the nature of reality. He continued to draw diagrams, write treatises, and imagine experiments, demonstrating that the human spirit can persevere even under the most oppressive conditions. His isolation became, paradoxically, a space for continued intellectual growth and creativity. Galileo's trial and punishment had broader implications beyond his personal suffering. It was a moment that highlighted the tension between science and religion, evidence and authority, curiosity and control. His ordeal became a symbol of the struggles faced by anyone who seeks to challenge convention, question dogma, or pursue knowledge in the face of powerful opposition. For Galileo, the injustice of the trial must have been deeply personal. He had sought only to understand and explain the universe. His work had been guided by reason, observation, and meticulous calculation. Yet he faced censure and restriction because his discoveries challenged interpretations of Scripture that had held sway for centuries. It was a bitter lesson in the cost of intellectual courage. And yet, despite the trial, despite the threat of punishment, and despite the limitations imposed by house arrest, Galileo remained undaunted in spirit. He continued to study, to write, and to dream. His observations, discoveries, and methods would endure, influencing generations of scientists, philosophers, and thinkers. The universe he had spent a lifetime exploring could not be silenced, and neither could the principles he had established. In the end, Chapter 9 of Galileo's life, marked by trial, threat, and house arrest, demonstrates the resilience of the human mind. Galileo had faced the full force of institutional power, yet he preserved his curiosity, integrity, and dedication to truth. The trial was a public humiliation, but it could not erase his discoveries. Nor could it prevent the eventual acceptance of heliocentrism and the broader scientific revolution he had helped ignite. Galileo's experience under the Inquisition serves as a reminder that the pursuit of knowledge is rarely easy. It requires courage to observe what others cannot or will not see, wisdom to navigate social and political realities, and resilience to endure setbacks. Even when forced to deny what he knew to be true, Galileo found ways to continue advancing science, leaving a legacy that would outlive his confinement. The trial, the threats, and the sentence of house arrest were a dark chapter in Galileo's life, but they also underscored his extraordinary character. He had been tested not just as a scientist, but as a human being, challenged to preserve truth, reason, and integrity in the face of fear, power, and institutional pressure. And even in this chapter of adversity, Galileo continued to inspire generations to come. Galileo's punishment could confine his body, but it could not silence his mind. It could not erase the mountains he had seen on the moons orbiting Jupiter, or the evidence for a sun-centered cosmos. His discoveries had been made, his methods established, and the universe itself continued to move, whether the church or any human authority recognized it or not. In the quiet of house arrest, Galileo persevered. He wrote, calculated, and reflected, preparing the final contributions of his life. His mind remained as sharp as ever, a testament to the enduring power of curiosity and the human spirit. Even under constraint, he continued to look upward, measure, and understand, proving that true knowledge cannot be contained. Chapter 9, The Trial and Punishment, marks the turning point where Galileo faced the might of the church directly. It is a story of courage under duress, the conflict between authority and reason, and the perseverance of a mind committed to truth. Galileo endured the humiliation and restriction, yet his legacy continued to grow, ensuring that the discoveries he made and the methods he championed would shape the course of science for centuries. Even in confinement, Galileo Galilei remained the same fearless observer of the cosmos, the relentless seeker of truth, and the father of modern science, a man whose discoveries could not be erased, no matter the threats or the chains of house arrest. After decades of brilliant discovery, relentless curiosity, and turbulent conflict with the church, Galileo Galilei entered the final chapter of his extraordinary life. By the 1630s, he was no longer the vigorous young scholar, dropping spheres from the Leaning Tower of Pisa, nor the celebrated professor observing Jupiter's moons from his telescopes in Padua and Florence. Age, illness, and the burdens of house arrest had begun to weigh heavily on him. Yet, even as the world around him became quieter, Galileo's mind remained as vibrant and relentless as ever. One of the most difficult challenges of these final years was his failing eyesight. By the late 1630s, Galileo had begun to go blind. The telescope, which had once opened the heavens to him, could no longer assist his eyes. The sketches of lunar craters, the careful tracking of Jupiter's moons, the delicate calculations of planetary motion, these tasks, so central to his life's work, became increasingly difficult. Blindness could have silenced many, but not Galileo. His intellect, his memory, and his reasoning remained sharp. He had spent decades observing the universe, internalizing patterns, measurements, and principles of motion. Even without sight, he continued to think mathematically, reason logically, and compose profound works of science. His mind had become a telescope of its own, capable of reaching beyond the limitations of his failing vision. During these years, Galileo continued to write. He dictated manuscripts, worked with assistants, and meticulously reviewed his ideas. One of his most remarkable works from this period was Discourses and Mathematical Demonstrations relating to two new sciences. Published in 1638 while he was under house arrest and partially blind, this book focused on motion, inertia, and the strength of materials, forming the foundations of modern physics. In this work, Galileo analyzed how objects fall, how projectiles move, and how structures withstand stress. He demonstrated that motion could be described mathematically, establishing principles that would later be expanded by Newton. Even in isolation, even under restriction, even without sight, Galileo's mind remained a force of innovation. The two new sciences were his gift to humanity, encapsulating decades of careful observation and experimentation into a coherent framework that would transform physics forever. Yet, while his scientific achievements continued, life under house arrest was not easy. The bright curiosity that had driven him to explore the heavens now had to contend with solitude, health issues, and the lingering humiliation of the Inquisition's condemnation. Galileo could no longer teach in public, debate openly, or advocate for the heliocentric system that he knew to be true. Despite these restrictions, Galileo's spirit remained unbroken. Letters from this period reveal a man who, even in adversity, sought to inspire others, share knowledge, and continue exploring the natural world. He corresponded with students and colleagues, advising on experiments, clarifying principles, and encouraging them to observe, measure, and question. His influence was not limited by walls or blindness. It traveled through his words and ideas. Galileo's personal life in these final years was quieter than the tumultuous periods of fame, patronage, and trial. He spent his days in reflection, writing, and careful observation of what could still be studied from his home. Though physically confined, he remained mentally free, pondering the motions of objects, the behavior of materials, and the mysteries of the universe. The very limitations imposed upon him seemed to strengthen his focus on the fundamental principles of nature, which he understood better than anyone alive. As the years passed, Galileo's health declined further. He suffered from fevers, weakness, and increasing blindness. Yet even as his body failed him, his legacy continued to grow. Students, scholars, and scientists across Europe studied his works, applying his principles and building upon his discoveries. The seeds of modern physics, astronomy, and scientific reasoning had already been sown, and they began to flourish even while Galileo lived in relative isolation. On January 8, 1642, Galileo Galilei passed away in Florence at the age of 77. The man who had once looked through a crude telescope and seen moons orbiting Jupiter, who had dropped spheres from the Leaning Tower of Pisa to understand motion, who had written the dialogue concerning the two chief world systems in defiance of authority, was gone. The house that had held him under arrest now held only memories of a life defined by curiosity, courage, and intellect. Galileo's death marked the end of a life that had shaped the course of human knowledge. Yet the story of his influence was far from over. The works he had written during confinement, the observations he had made, and the methods he had championed, empirical observation, experimentation, and mathematical reasoning, would live on, inspiring generations of scientists and thinkers. In the centuries that followed, Galileo came to be honored as the father of modern science. His insistence on observation over tradition, evidence over authority, and mathematics as the language of nature transformed the way humanity understands the universe. Newton, Kepler, and countless others built upon his foundations, and the principles he articulated remain central to physics and astronomy today. Galileo's life story, from the curious boy in Pisa, to the celebrated professor in Padua, to the court scientist in Florence, to the condemned and blind scholar under house arrest, serves as a testament to the resilience of human intellect and the power of reason. His trials reveal the tension between innovation and authority. His discoveries reveal the boundless potential of careful observation, and his writings demonstrate the importance of communicating complex ideas with clarity and persuasion. Even as he faced blindness, confinement, and censure, Galileo continued to believe in the truth of the universe. He had seen the moons of Jupiter, mapped the lunar mountains, and described the laws of motion. He had challenged centuries of accepted belief, risking fame, security, and personal safety to pursue understanding. His life was a story of curiosity, courage, and persistence, showing that the human spirit can endure and even flourish under extraordinary adversity. Galileo's legacy extends beyond astronomy or physics. He transformed the method of inquiry, establishing that nature could be understood through observation, mathematics, and experimentation. He showed that questioning authority is not rebellion but a vital part of discovering truth. He demonstrated that knowledge is a universal pursuit, one that cannot be confined by fear, politics, or dogma. Even today, centuries after his death, Galileo's influence is felt in classrooms, laboratories, and observatories worldwide. His methods underpin scientific inquiry. His discoveries inspire wonder, and his story reminds humanity of the courage required to seek truth. The telescope, which once brought distant moons into focus, became a symbol not only of observation but of the human drive to explore and understand the universe. Galileo's life, particularly his final years, teaches an enduring lesson. The pursuit of knowledge is rarely smooth or easy. It often requires patience, resilience, and unwavering belief in the evidence of the senses. Even when constrained, when blind, when silenced, a mind devoted to understanding the natural world cannot be fully contained. By the time of his death, Galileo had transformed the world. He had reconciled observation with mathematics, reason with wonder, and curiosity with discipline. He had challenged authority without abandoning integrity. He had endured the trials of the Inquisition yet continued to contribute to human knowledge. Galileo Galilei, the boy from Pisa, the scientist of Padua, the court scholar of Florence, and the condemned genius under house arrest, left behind a legacy as enduring as the heavens. He observed. He proved that the universe could be understood, that evidence matters more than authority, and that curiosity, courage, and intellect are the most powerful forces of all. His life was a story of discovery, struggle, resilience, and triumph, not in worldly rewards, but in the eternal expansion of human understanding. And though he could no longer see with his eyes, Galileo's vision, the vision of a universe governed by law, order, and reason, continues to guide every generation of scientists who follow in his footsteps. Galileo may have died in 1642, but his influence remains timeless. His work, courage, and methods endure as a beacon, reminding us that to seek truth, to question boldly, and to observe carefully is the highest calling of the human mind. He is, and will forever be, the father of modern science, a man whose life reminds us that knowledge, once discovered, can never be confined. As we come to the close of this journey through the life of Galileo Galilei, it's worth pausing to reflect not only on the events of his life but on the lessons that echo through centuries. From the streets of Pisa, where a curious boy first wondered why objects fall, to the quiet nights spent staring through telescopes, to the halls of power in Rome where he faced judgment and censure, Galileo's story is a testament to the courage of human thought. Galileo proved something extraordinary. That truth can be dangerous. The discoveries he made, which today seem so obvious, once carried the risk of punishment, isolation, and humiliation. A simple observation: a moon orbiting Jupiter, a peak on the moon, a planet showing phases, was enough to provoke fear in the minds of those who wielded authority. In Galileo's time, seeing the truth was not always celebrated. It was sometimes condemned. And yet, he continued. Even when threatened with the Inquisition, he never stopped observing, questioning, and reasoning. He made a choice that many might not understand. He chose survival. Galileo recanted under threat of punishment, accepting house arrest instead of risking torture or death. Yet this choice was not surrender. In the quiet confinement of his home, he continued to write, calculate, and refine the laws of motion and mechanics. He showed us that courage does not always mean direct confrontation. Sometimes it means finding ways to persist despite limitations. His intellect could not be imprisoned, and his curiosity could not be extinguished. Galileo's legacy reaches far beyond his own era. The work he produced in observation, mathematics, and mechanics laid the foundations for Isaac Newton, who would formalize the laws of motion and gravity centuries later. Newton's achievements, in turn, became stepping stones for Albert Einstein, whose theories of relativity reshaped our understanding of space and time. Every discovery Galileo made, every principle he articulated, became part of a chain of knowledge that continues to shape modern science. The universe that Galileo explored with his telescopes is now mapped by satellites, studied by astronomers, and understood in ways he could scarcely imagine. But it all started with the curiosity of one man daring to look beyond the obvious. Galileo's story is also a powerful reminder that time can vindicate truth. Once punished, once condemned for challenging authority, Galileo is now celebrated across the world. Statues, museums, and awards bear his name. Students in classrooms study his discoveries. Astronomers and physicists honor him as the father of modern science. The very ideas that once put him in danger are now the foundation of knowledge, illustrating that courage and curiosity often outlast fear and oppression. From a stargazer in Pisa to a legend in science, Galileo's life shows us the journey of human understanding itself. He taught humanity not just to look at the stars, but to think critically, question boldly, and rely on evidence. He demonstrated that knowledge is not a gift to be given by authority, but a truth to be discovered through observation and reason. He modeled what it means to be both human and visionary, curious, resilient, and persistent, even when the world seeks to suppress your ideas. And as we reflect on his life, it's natural to see parallels in our own world. In science, in learning, in creativity, and even in daily life. There are moments when questioning, exploring, or thinking differently can feel risky. Galileo's story reminds us that growth and discovery often come with discomfort, challenge, or resistance, but that those challenges are worth facing. Every time we question, observe, or explore, we are continuing the legacy of those who dared to think beyond the limitations imposed by their time. For anyone watching this video, take a moment to appreciate the power of curiosity. Galileo didn't just study the heavens, he showed us a way to approach the unknown with courage, patience, and reasoning. He reminds us that the universe is vast, complex, and beautiful, but it can be understood by those willing to look carefully and think deeply. If you've enjoyed this exploration into the life of Galileo, I'd love it if you could show support for this channel by liking the video. Liking helps more people discover these stories, ensures that the effort to bring history alive is appreciated, and motivates us to produce even more in-depth, engaging content. And if you haven't already, make sure to subscribe to the channel. By subscribing, you become part of a community that values curiosity, learning, and the deep stories behind history's greatest figures. It's more than just a button. Subscribing connects you to content that inspires, educates, and brings history to life, just like we've explored in Galileo's story. As we look back one final time on the journey of Galileo Galilei, imagine him in the quiet of his home, partially blind, under house arrest, yet still thinking, calculating, and writing. He had faced the church, faced punishment, and faced personal loss, but he had not surrendered his mind. The stars continued to shine above him, and through his observations and reason, He had made the universe a little clearer for everyone who came after. Galileo's life teaches us that legacy is built not only by what we see, but by what we do with what we see. He looked at the moons of Jupiter, the mountains on the moon, and the phases of Venus, and he chose to write, to calculate, and to share, even when danger threatened. Every discovery he made became part of a larger story of humanity's quest for knowledge, a story that continues today, in every classroom, laboratory, and observatory. So as we end this video, remember the words that capture the essence of Galileo's life. Galileo didn't just look at the stars, he taught humanity how to think. He showed that curiosity, courage, and reason can illuminate even the darkest corners of ignorance and fear. He demonstrated that ideas, once discovered, can never be truly silenced. And he proved that the pursuit of knowledge is one of humanity's most enduring and noble endeavors. If this story inspired you, take a moment to like this video, share it with friends who love history and science, and subscribe to the channel to explore more stories of extraordinary lives. By doing so, you're not just supporting the channel, you're becoming part of the journey of curiosity and learning. Just as Galileo inspired generations to look at the stars and think deeply. As we leave the life of Galileo behind, let his story remind us, the universe is vast, full of mysteries, and waiting for those bold enough to observe, measure, and question. Whether you are a student, a teacher, a scientist, or simply a curious mind, the example of Galileo encourages you to never stop thinking, to never stop exploring, and to never let fear silence the truth. From stargazer to legend, Galileo's life is more than history, it is an inspiration. And as we turn off the telescope and close the pages of his story, remember that the journey of understanding continues, and each of us can carry forward the courage, curiosity, and brilliance that Galileo embodied. So once again, like, subscribe, and join this journey of discovery, because there are countless stories waiting to inspire, educate, and transform the way we see the world. And just like Galileo taught humanity how to think, every new story, every new discovery, is a chance to do the same.